We're on the last problem, number 16 from page 3 of your packet. And I'm going to do this one in the lazy way too, just because I want you to see that there are ways to make up for the fact that you have limited amounts of space. So I'm looking at this. It's actually 3 different rational expressions. And remember, your strategy is factor denominators only first. So I'm looking right here. This denominator, there's nothing that can be factored, x plus 2. The second term's denominator is x minus 1. That can't be factored. This trinomial, x squared plus x minus 2, might be factorable. And let's see if I can figure that out. If I have 2 numbers that multiply to give me negative 2, which is probably going to be a 2 and a 1. I just need to figure out where to put the positive and the negative. And add to give me a plus 1. That means that the bigger number gets plus, because plus is what is here, and the other one, the 1, is what gets the minus. So this ends up being x plus 2 times x minus 1. When you have factored, you have replaced this problem. So I'm going to mark through that because I have now replaced it with a new pair of binomials. So now it's a little game of I have, who has. The first thing you need to do is look right here, x plus 2. Who else has x plus 2? That one does. But the middle term doesn't, which means you have to multiply by, let me scooch this little guy over. You have to multiply by x plus 2 over x plus 2 so that it's a common denominator. So now the middle term has an x plus 2 also. Then you look at what's left, and I've got an x minus 1 in the third term, and x minus 1 in the second term. I do not have one in the first one, and I need one. So I'm going to multiply by x minus 1 over x minus 1. Now I can make that one pink. So now that I see that everything is either pink or yellow, and they all have everything that's the same, I know for a fact that my factored common denominator is going to be x minus 1 times x plus 2. Okay, so now I'm just going to have to do the math in the numerator. So once you've found your common denominator, do your math in your numerator. So I'm multiplying 5x across x minus 1. So that would be 5x squared minus 5x. Okay, this is a negative x. Negative x across x plus 2. So it's going to be minus x squared minus 2x. Okay, and then I just have a plus 3 on the end. So you're going to combine your terms, and again, I'm assuming that we are working in an environment where space is not there. So we're going to combine like terms, and I've got, if I have a 5x squared minus x squared, that gives me 4x squared. Okay, if I have a negative 5x and a negative 2x, that gives me a minus 7x. And then I've got a plus 3 left over. I have replaced that with 4x squared minus 7x plus 3. So I'm going to factor that, and I'm looking for what are the factors of 4 times 3 is 12 that add up to negative 7. I don't know, but sometimes I just do a factor list. 1 times 12, there's no way. By the way, this term tells you whether you're going to be adding or subtracting. Plus means you should be adding your terms. 1 plus 12 is not going to be 7. It's going to be 13. 12 is 2 times 6. I can't get a 7 from that. 3 times 4, there they are. 3 times 4 is 12, and you can add them to get a 7. So if you've got 12 and negative 7, that means that it's going to have to be negative 3 and negative 4, right? If negative 3 plus negative 4 is equal to negative 7, but when you multiply them, you get a positive 12. So I'm going to factor this, and this is going to end up being, and remember that I factor funny. I do it like this. I go 4x, you know what, let me do this. I told you that I'm doing this because space is tough, but I am going to just move this down just a little bit and see if it works. Okay, it did. No, it didn't. All right, let's see. Oh, yeah, it did. Hold on. I'll tell you what I'm going to do. I'm going to zoom way in. and go to a smaller pencil. Okay, so remember that we said it's -3 and -7, or -3 and -4, right? I don't do any funky things with that. I rewrite this expression, and I rewrite it like this. First of all, I take 4x squared and leave it alone. I take the +3, I leave it alone. Okay, so the first and last terms aren't the issue. In the middle is where I've got to go -4x minus 3x. -4x minus 3x, if you combine them, it is -7x. I haven't changed what that expression means, the trinomial. All I've done is split it. Okay, so now I've replaced that. I'm going to mark through it because I've replaced that. Here's why I did that. I look for common terms in the first two, and I see that if I take a 4x out of that, what I get is x minus 1. And then I do the second one. If there's a negative there, the common term is going to be negative. So I'm going to take a negative, and they both have a 3. So a -3 from -3x was x, and a -3 divided into a +3 is going to be -1. Okay, I have now replaced that. The reason that I did that is because I realized, and I'm going to go down here, I typically wouldn't do this, but I'm out of room. If you look at this expression, you can actually factor an x minus 1 from the entire thing. If you take x minus 1 from both of those terms, x minus 1 times, so it's gone from both of those now, what would be left is a 4x minus 3. Okay, so I've replaced that now, which means x minus 1 times 4x minus 3 is what's left in the numerator, and x minus 1 times x plus 2 is what's left in the denominator. If you look, x minus 1 over x minus 1, that cancels, and what you end up with is 4x minus 3 over x plus 2. And ta-da, that's the last one.